So first of all, dissolving versus dissociating, what's the difference? Well, we're not too concerned if something dissolves, because dissolving is simply that process of making a mixture, right? Making a homogeneous mixture with a solvent. Like if you think of something dissolving in water, that's what we're talking about. And that's not really of a lot of interest to us. Like, who cares if it dissolves? But does it dissociate? Because dissociation is an extra step. First of all, in order to dissociate, your substance must dissolve. So notice that that's sort of there. Anything that doesn't dissolve will also not dissociate. But dissociation is an additional process of splitting into ions. The splitting into ions during the dissolving process. So what I mean by that, sugar. Sugar is the compound that dissolves, right? If we're talking about glucose, C6H12O6, it absolutely dissolves in water. But it doesn't dissociate. It doesn't split into ions, which means that I know that the chemical species that is in solution with glucose is just C6H12O6. However, salt, NaCl. Now it is an ionic compound, and it absolutely dissociates in water, which means that when you have NaCl aqueous, it's not really NaCl aqueous. That's not actually what it is. What it really is, it's the NaCl has split into its ions, and what you really have for anything that dissociates, but in this case with salt, is Na plus aqueous and Cl minus aqueous, but the ions have split apart. They have dissociated. And understanding that things that can dissociate, that this is what they're actually going to look like in solution, is a huge thing for us. And we have to start seeing ions as being separated, as being dissociated in solution, so that we can understand their chemistry a little bit better. So just an example, we're going to write the dissociation for some soluble ionic compounds. Now, I told you that these suckers are soluble, which means that I'm telling you that they do dissociate completely. And if we take the first one, ammonium bromide, there are two ions in this thing. There's the ammonium ion, NH4, and then there's the bromide ion, Br. So when this splits, it's literally just going to split into those ions, and there's one of each. So I'm just going to write one NH4 plus and one bromide, and that's actually what you have in solution with ammonium bromide. You do not have the combined compound. It has totally split into the two separate ions. Now calcium chloride, again, there are two ions in this. There's calcium and there's chloride, but the number of each, I've got one calcium, which I can tell from the subscript, but I have two of the chlorides. So this is not Ca plus Cl2. That is not what it splits into. It splits into the ions calcium, which has got the +2 charge, remember group 2, and the chloride ion, but there are two of them coming from the subscript for the ion. So you got to be really, really careful. It's not Ca and Cl2, it's Ca and two Cls. That's what it splits into. Again, it doesn't actually exist as CaCl2. It does exist as one calcium and two chloride ions just kind of floating around. Next up, magnesium nitrate. The two ions are magnesium and nitrate. So that's what we're going to write as the products. Knowing our charges, right? Magnesium group 2, so it's +2 nitrate, memorizing that because that's a big polyatomic that we have to know. But there are two of the nitrate ions, so I'm just going to write a 2 right there. And I no longer have any magnesium nitrate in solution. I do, however, have lots of magnesium ions and nitrate ions. And lastly is potassium phosphate. So the ions in this, I've got K, and I have PO4, and I know that in this case the PO4, the 4 is really just belonging to the polyatomic. That's why we memorize these things, so that we recognize them when we see them. So this is going to split into potassium ions and phosphate ions, and we're going to memorize that the phosphate has the -3 charge. But there are 3 potassiums, so I'm going to make sure that I write that there. And I no longer have any K3PO4, but I have lots of potassium ions and lots of phosphate ions that are floating around in solution. An electrolyte.